Well, now let me use an example to demonstrate how to use SAW to find the answer for a problem. Let's read the problem together. In a particular experiment, a volumetric flask is used to determine the density of an insoluble solid. At the beginning, the volumetric flask was measured to be 35.093 gram. After a certain amount of an unknown solid was added to the volumetric flask, the total mass was 42.382 gram. At the end, water was added to the volumetric flask. To reach the mark to indicate the total volume is 25.00 milliliter. The total mass was 61.359 gram. If the density of water is 0.99928 gram per milliliter, what is the density of the unknown solid? The first step to use SAW is to summarize. To summarize means we will rewrite the most important information. The most important information includes numbers with units, what we are looking for, and balanced chemical equations if there are chemical reactions in the problem. But when we read the problem, we do not have any chemical reaction in the problem. Therefore, our summary should only include numbers with units and what we are looking for. When we read the problem, we have 3 masses. Therefore, we'd better to make some little drawings to indicate the difference of the masses. Well, let's start from the beginning. When we read, the first number with unit is the volumetric flask mass. Let's draw an empty volumetric flask first. Well, from the problem, the mass of the empty volumetric flask is 35.093 gram. Let's continue to read. When we add the unknown solid to the volumetric flask, the total mass becomes 42.382 gram. Well, the second drawing will be the volumetric flask with the unknown solid. Theoretically, these 2 flasks should be exactly the same, but when I draw, I cannot draw them exactly the same. We need also to draw some solid. I will use some circles to represent the solid. Well, from the problem, the total mass is 42.382 gram. Well, when we continue to read, we find that when we add water, flask, and unknown solid together, the total mass becomes 61.359 gram. Well, the third drawing should be the flask, solid, and water to the mark. We should draw the same number of circles to represent the same solid. The mass is 61.359 grams. We also know the total volume is 25.00 milliliter. From the problem, we know the liquid we added to the volumetric flask is water. You can write down water or H2O. Then we also know the density of water is 0.9992 gram, 28 gram per milliliter. Then we need to write down what we are looking for, the density of the unknown solid. Or I suggest you to write down density of the solid, because we have 2 different densities. Well, since we have 3 different masses, we'd better to give them different symbols. Let's call them M1, M2, and M3. The second step of using SAW is to analyze. We want to start from what we are given to find a path to what we are looking for. Well, let's start from what we are given. Let's see what we can get directly. Since we know the mass of the empty volumetric flask, and we know the mass of the flask with the solid. From these two masses, we can find the mass of the solid only. Similarly, we can find the mass of the water only from the mass of the water, solid, and the flask, and the mass of the flask plus the solid. Well, at this point, you may not know how to proceed. Sometimes when you are using SAW, you can also start from what we are looking for. If we are looking for the density of the solid, if you recall, we have only learned one equation, which is the definition of the density of the solid. Well, let's put it down. The three-line symbol indicates this is a definition. Then, let's look at what we're given, what we can calculate, and what we're looking for. From our calculation, we already know the mass of the solid from this calculation. But we don't know the volume of the solid. Let's read what we're given. We know total volume, which is the volume of the solid plus the volume of the water. Let's put this down. Although it may not be useful, but we will put this down. At least this relationship includes the volume of the solid. If we can find the volume of the solid, then we can calculate the density of the solid. Let's see if we can find the volume of the solid or not. Well, we know the total volume. If we know the volume of the water, we can get the volume of the solid. Let's see what we have about water. We know the density of water. We also know the mass of the water. If you really know the density formula well, then you will immediately realize that we can calculate the volume of the water from the mass of the water and the density of the water. Well, it seems we can calculate the density of the solid from what we are given. Well, after our second step, this is what we are going to get. Now let me tell you the trick, how to use this map. When we are using this map, we always start from places whenever there's no arrows point to. We can start from any of these numbers, but we cannot start from here because there are arrows point to them. As I just said, you can start from anywhere there's no arrows point to. Then you can follow the arrow and finally to reach your answer. Well, let's start from here. We can start from M1 and M2. We can get the mass of the solid. This will be our first step. We can also start from M2 and M3 to find the mass of water. This can be our second step. Then we will follow the arrow. If we know the mass of the water and the density of the water, we can calculate the volume of the water. Let's call this third step. Then, after we get the volume of the water, we can calculate the volume of the solid. This will be our fourth step. If we know the mass of the solid from the first step and the volume of the solid from the fourth step, we can calculate the density of the solid. This will be our fifth step. It's also our last step. Now let me show you the details of all steps. Once you get the second step done properly, this step will be relatively easy. Let's start from step 1. Well, we're done, but I want to emphasize, during exam or quiz, these are what I'm looking for. You do not need to provide me with this map.